Okay, continuing on. Now earlier we had homogeneous linear systems, and this is where b was equal to 0, and thus the equation was ax is equal to 0. Now for other types of systems, okay, we're going to have non-homogeneous, and non-homogeneous, okay, you have that ax is equal to b, which this time is going to be non-zero. So this is going to state that there does not exist a non-zero vector such that ax is equal to 0. And a case of a non-homogeneous linear system is going to be where we have in the following. Okay, we have with the system, we have solving in terms of x01, x2, x3. We have the coefficient matrix where we have in the top row, we have 4, 1, -5. Bottom row, we have 1, -2, -8. And we have with this time the non-zero matrix B, which we have at 0 and 9. And for the augmented matrix, as we combine A and B, okay, have row operations will produce the following. Okay, so I can interchange, okay, the resulting top and bottom rows, okay, and just have one at the top, 4 at the bottom in the first column, and I can make the 4 into a 0, so I can take 4 times the first row elements from the second row elements. Okay, so I get this result. So we have going from 4, 1, -5, 0 to 0, 9, 27, -36. And with the leading element at 9 and looking at progressing to reduced echelon form, I can convert the 9 to a 1, taking 1/9 of the second row. So in this case, I have 0, 1, 3, and -4. And if I continue, so I've just duplicated here, and so I got 1 and 0. And if I have for the next pivot position, you have the 1 at the bottom, and I can make the -2 into a 0. So for this to take place, I can take 2 times the second row elements and add to the top row, whereupon we're going to have 1, 0, 14, 1 at the top, and at the bottom I have 0, 1, 3, and -4, and this is going to be our reduced echelon form. Okay, so first column have reference to x1, next x2, third x3, and then we have constants to which each equation is going to be set equal. So we have for x01, this is going to be equal to 1 minus 14 times x3. And then we have from the second row, we're going to have x2 is equal to -4 minus 3x3. And again, since there was no leading non-zero element that could reference x3, x3 is going to be a free variable. And so we have for ax is equal to b equals 0, 9. This is going to have a general solution, and this is going to reference what we have in x of 3. So we have x is equal to, okay, you have the vector x of 1, x of 2, x of 3, and we have equal to, and again, in terms of x of 3, we have x of 1 is at 1 minus 14 x of 3, x of 2 becomes -4 minus 3 x of 3, and again we have x of 3 is equal to itself. And then we have extracting. Okay, so if you notice, we don't have 1 or -4 attached to x of 3. So if we separate the constants apart from the variable terms in x of 3, so we'll have from the top, I have 1, middle, I have -4, and since we have the bottom row to consist of only x of 3, you could read this as if it were 0 x of 3. So we have 0 in the vector that has only constants, and then for the variable terms, you have factoring out x of 3, have -14, -3, and 1. So this will be your general solution for this particular system. Okay, so for what we have in the second system, okay, we have 2 matrices. Okay, when we have the coefficient matrix A, we have the top row at 1, 1, 0, 3, bottom row we have at 0, 0, 1, 4, and we have B as a non-zero matrix where we have 4 at the top, 7 at the bottom. And if I combine these as an augmented matrix, okay, the combination is already going to produce the row echelon form. Okay, so you have 1, 1, 0, 3, 4, 0, 0, 1, 4, 7. And okay, so we have for the first pivot position, you have upper left-hand corner 1. This will make reference to x of 1. And if I isolate this, it's going to be forming 4 minus x of 2. There's no x of 3 term. And then we have minus 3x of 4. And with the next pivot position, notice, okay, we have that is going to exist in the third column. And since there's no non-zero leading elements in the second column, okay, there's nothing that is going to isolate x of 2, so x of 2 is going to be a free variable. But now with x of 3, okay, since the leading element in the second row is the one which references x of 3, that's going to be equal to 7 minus 4 times x of 4. And now x of 4, since there's no formed row, that's going to lead to a non-zero leading element in the fourth column. X of 4, just like x of 2, is going to be a free variable. And so we have for ax is equal to b is equal to 4, 7. This is going to have a general solution whereupon we're going to have that x is equal to x of 1, x of 2, x of 3, and x of 4. And writing in terms of the free variables, okay, x of 2 and x of 4. Again, we have with x of 1, I have 4 minus x of 2 minus 3 times x of 4. And again, with the free variable x of 2, that's equal to itself. For x of 3, I have 7 minus 4 times x of 4. And again, x of 4 is a free variable, so it is equal to itself. And then separating, okay, so if we take, say for the first matrix, once we split up, okay, so you have with the constants, from the top I have 4, next I have nothing, and then I have 7, and where the free variables are situated, again, we have no constant, just 0. So we have from the first items, so we have with the constants, I have 4, 0, 7, 0, and then forming our next vector and factoring out x of 2. So from the top I have -1, +1, and since x of 2 does not exist in the last two rows, okay, we're going to fill in with zeros. And then we have with x of 4, okay, top from x of 1 I have -3, x of 4, and again x of 2 is a free variable and it does not reference x of 4. It also have a 0 here. And then we have from x of 3, again the 7 is in the column of constants. And for minus 4x of 4, okay, so we have in the last matrix, okay, with x of 4 factored out, I have -4. And we have for x of 4, that's x of 4 times 1. So for our general solution, again, we have the constants, and then we have that which references row by row what we have in x of 2, and then we have with the last matrix that which references what we have for x of 4. So this is going to be our general solution